Hello everyone, welcome to our mathematics session. In this session, we are going to discuss about some mathematical problems related to number system of ninth standard. Okay, dear students, we have already learned about the rational numbers. The rational numbers, all of you know, the numbers which can be expressed in the form p by q, where the denominator q is not equals to 0, where q is not equals to 0, and p and q both are integers. Okay, so rational numbers are the numbers that can be expressed in the form of p by q, are called rational numbers. Okay, and the most important thing, what are the types of the decimal expansion can a rational number have? Before that, which are the numbers that can be expressed in the form p by q, we must learn. All the natural numbers from 1 to infinity, 1, 2, 3, 4, etc. up to infinity are termed as rational numbers. They are also the rational numbers because they can also be expressed in the form p by q. That means, say for example, if you take 2, then 2 can be written in the form 2 equals to, can be written as the form 2 by 1. That means of the form p by q, isn't it? P by q, where q is a non-zero quantity. So as 2 is written in the form p by q, that is 2 by 1, so 2 can also be categorized as rational number. And same in the case of 3. 3 can also be written in the form 3 by 1, that means p by q. That means 3 can also be expressed in the form p by q, so it is also a rational number. Even 0 also is a rational number because 0 can also be written in the form p by q. That means you know that 0 by anything is 0. So 0 by 1 we can write, or 0 by 2 also we can write, 0 by 3 also you can write any other such type of expressions. So it will give you certainly 0. That means 0 is also a rational number as it can be expressed in the form p by q, where q is non-zero quantity, non-zero integer, right? So rational numbers, whole numbers are rational numbers, natural numbers are rational numbers. Rational numbers are those numbers that can be expressed in the form p by q. Okay, and let us talk about any other fractions. Suppose 2 by 3. This is also a rational number because it satisfies the condition of rational number. It is expressed in the form p by q and q is non-zero quantity. Therefore, it is also a rational number. But it is not a whole number because if you divide it, you will get a decimal expansion. Something like it will be 0.666, it will go on. Okay. And 1 out of 2, that is also a rational number because it can be expressed in the form, it is expressed already in the form p by q, so it is a rational number. And as the denominator is a non-zero quantity, and if you divide it, you will get a decimal expansion or terminating decimal expansion. Its decimal expansion like the 0.5. Okay, but these are the whole numbers. That means 2 by 1, its value is 2 itself. So 2 is a whole number or natural number. Any natural number or any whole number are the rational numbers, but it is not necessarily that whole numbers will always be rational numbers mean always the whole number, or all the rational numbers means a natural number only. It is not true. That means, let me clarify. You know that natural numbers 1, 2, 3, 4, 5, etc. These all are all rational numbers too. They are also rational numbers. But 0, including 0, that means all the whole numbers are rational numbers. But not necessarily all the rational numbers are natural numbers. All the rational numbers are not necessarily the whole numbers even, because rational numbers, to be a rational number, the condition must satisfy is the number is expressed in the form p by q or not, where q is non-zero quantity. If any expression or any quantity, any term is expressed in the form p by q, then it can be rational number, but it is not necessarily be a whole number. That means if we take the same example, that is 2 by 3, if you divide it, it will certainly not, it is not a whole number. It will have a decimal expansion like 0.666666. Got it? That means rational numbers include all the natural numbers, all the whole numbers, then any other fractions also. Okay. Now, the types of the decimal expansion a rational number can have. As you know, rational numbers can have two types of decimal expansion. All the rational numbers which are expressed in the form p by q can have two types of decimal expansion. One is terminating decimal expansion and the other is non-terminating but repeating decimal expansion. One is terminating decimal expansion, as you have noticed in the case 1 out of 2, that is 1 by 2. When you divide it, when you try to divide it, you get 0.5, which is exactly terminating decimal expansion. That means when you divide it, you will get the remainder 0, and when you get the remainder 0, it will be a terminating decimal expansion. Okay, it will give you a terminating decimal expansion. And the other one, that is 2 by 3. When you divide it 2 by 3, then you get repeatedly repeating digit, that is 6 was repeating. It is never ending, it will go on, it will go on. That means a rational number which is expressed in the form p by q can have two types of decimal expansion. That is, one is called the terminating decimal expansion. When you look at the terminating decimal expansion now, yes, when you divide and after division, when you get the remainder 0, that means after decimal expansion, at a certain place, it will get terminated. And the other one, that is 2 by 3 when we took, then when you divide it, when you perform the long division, you will get repeatedly repeating block of numbers, or it may be a single digit. Okay, so it will go on repeating, never ending, that means. So from this we can conclude that a rational number can have two types of decimal expansion. One is terminating decimal expansion and the other is non-terminating but what? Yes, but repeating decimal expansion. Non-terminating but repeating, and the first one was terminating. So rational numbers can have two types of decimal expansion. You can note it also, okay? Rational numbers can have two types of decimal expansion. One is terminating decimal expansion and the other is non-terminating but repeating decimal expansion. Okay? Okay, there are certain numbers whose decimal expansions are neither terminating nor repeating. Okay, there are certain numbers you will get whose decimal expansions are of this kind. Say for example 0.10, then 100, then 1000, then 10000, and so on. So if you look at here, if you observe this decimal expansion carefully, you will get it is neither terminating nor repeating. How? Let's see. You will get after decimal there is 10. Then soon after that you will get 100, that is 100. If you omit the decimal and read it, then it will be 10, then 100, then 1000, isn't it? Then it is 10,000 and so on. So after decimal we have 10, then 100, 1000, 10000, and so on. So these are not a terminating decimal expansion. Are they terminating? Yes, you can see that there is 1 repeatedly coming in this number, in this decimal expansion, and zeros are also there which are coming repeatedly. But are they coming after certain interval or definite interval of time? No. They are coming like 10, then 100, then 100, and it will go on increase. So this is called non-terminating and non-repeating even. It is non-terminating because it will go on, and it is not repeating because there is 10, 100, 1000. That means none of this digit or number, whatever you say, it is not repeating. Is that clear? So we have got three types of decimal expansion now in all. That is, the first one is terminating. Okay, and terminating decimal expansion means they are rational numbers. They can be expressed in the form p by q. Terminating decimal expansions can be expressed in the form p by q. Okay, then non-terminating but repeating. They are also rational numbers. Okay, non-terminating but repeating. They are also rational numbers, and they can also be expressed in the form p by q. That is, any of this form, p by q. And the other form is, other decimal expansion is neither terminating nor repeating. If the decimal expansions are neither terminating nor repeating, then they cannot be expressed in the form p by q. They cannot be expressed in the form p by q. Cannot. Okay, and those numbers which cannot be expressed in the form p by q are called, yes, opposite of rational. It is called irrational numbers. Make it clear. We have got three types of decimal expansion. One is terminating, other is non-terminating but repeating. Both these cases gives us P by Q form. We can express them in the form P by Q, and they are called rational numbers. But the other form of decimal expansions are neither terminating nor repeating. So this type of decimal expansions cannot be expressed in the form P by Q. They cannot be expressed in the form P by Q. And any number, if they cannot be expressed in the form P by Q, they are exactly opposite to that of the rational. That means they are called irrational numbers. Okay. Say for example, if you see, you will get pi. Pi is irrational number because pi, it has neither terminating decimal expansion nor repeating decimal expansion. Okay. Then some other irrational numbers. So pi is also irrational number because its decimal expansion is neither terminating nor repeating. Then you will get root over 2, root over 3, root over 5, then root over 6, root over 7, root over 8. That means which are not perfect squares. Okay. The numbers which are not perfect square, their square root are also irrational numbers, because if we find their square roots, then we will get neither terminating nor repeating decimal block or decimal expansion. Sorry. So they are also irrational numbers. Pi is irrational number, root over 2 is irrational number. Similarly, if we try, you will get root over 3 is also irrational number, root over 5 is also irrational number, root over 6 is also irrational number, root over 7 is also irrational number, root over 8 is also irrational number, root over 10 is also irrational number. Have you noticed I have not written root over 4. What is root over 4? You know that root over 4 is equals to 2 and 2 is a whole number. So root over 4 is a rational number. Yes. Root over 4 is rational number because root over 4 is equals to 2, and you know that 2 is a whole number or 2 is a rational number, natural number also. So any whole number, any natural number are also the rational numbers. It can be expressed in the form P by Q. It can be expressed in the form P by Q. But at the same time, root over 5, root over 6, root over 7, root over 8, root over 10, root over 3 also, they cannot be expressed in the form P by Q, because if you find out their decimal expansion, it will go on. It will neither terminating, it is not even repeating. Is that clear? I have not written here about root over 9. Root over 9, you know, all of you know that root over 9 is equals to 3, and 3 is a whole number or 3 is a natural number also. So it is expressed, or it can be expressed in the form P by Q, so it is a rational number. So root over 9 is a rational, root over 4 is rational, but root over 3 is not rational, root over 5 is not rational, it is irrational, it is also irrational, it is also irrational, and so on. Root over 1 is also rational. That means square root of any perfect squares, they are the rational numbers, but which are not perfect squares are not even rational numbers, they are irrational number. It is because now in 9th standard, you must know that their decimal expansions are neither terminating nor repeating. Okay, but in 10th standard, you will be able to solve, or you will be able to prove that root over 3 is irrational. Okay. Here we have a question. The question is express 0.3333 ... So looking at the decimal expansion, you can say, or you have understood or think this is whether rational or irrational. What is this? Yes, very good. It is rational. Why it is rational? Because it's this decimal expansion is non-terminating, okay, but it is repeating, as 3 is repeating here, okay. So it is a rational number, and a rational number, the decimal expansion which is non-terminating but repeating, can be expressed in the form P by Q, as I said already a few minutes ago. So let us write its P by Q form. That means it's a fraction form. Okay, it's a rational number form. How to write? Okay, we'll learn in this session how to express such kind of decimal expansion in the form P by Q. So we will consider the given decimal expansion as x. Let us consider this late. We will write here late x is equals to 0.3333 and so on. We will make it as equation number 1. And as you have seen, only one digit is repeating here. Since only one digit is repeating, we will multiply this equation with 10. If two digits are repeating, then we will multiply it with 100. Okay, remember. So multiplying it with 10, multiplying equation 1, entire equation 1 with 10, you will get 10 times x. 10 times x. If you multiply this with 10, then it will become 3.3333. You can write 4 times 3 also, because it is repeating, because after this also 3 will be coming, and it is repeating up to the infinity. Okay, that's why you can write it here. And let us make it as equation number 2. Now let us subtract equation 1 from equation number 2. Equation 1 is to be subtracted from equation number 1. From equation 2. If you do so, left hand side minus left hand side, then what will it be? 10 times x minus x, and this side it is 3.3333 repeating minus 0.3333 repeating. What will you get? Yes, 10 times of x minus x will give you 9 times of x. Then from here to here, if you subtract it, it will give you, yes, 3.0. You need not to write 0. Okay, in this line we will write 3.0. Then 9 and x, they are multiplied with one another. If you shift this 9 that side, it will get divided. That is 3 by 9. And 3 by 9, all of you know it is x equals to 1 out of 3. That means x was considered as 1. X was considered as 0.3333. Okay, that means 0.333 is equals to 1 by 3. That means therefore 0.3333 can be expressed in the form 1 by 3. This is the rational number or p by q form of this decimal expansion. Okay. Let us take one more example. Express 0.13 bar. 0.13 bar in the form p by q. Okay. 0.13 bar. Solution. We will write let x is equals to 0. Okay, now 13 bar. Let us understand what is the meaning of 13 bar. So a bar is given above 13. It means 13. These two digits are repeating. That means it can be expressed in the form 13, 13, 13 and so on. It is repeating actually. That's why instead of writing like this repeatedly, a bar is put in on top. Say it is equation number 1. If you notice, if you see, observe it carefully, you will see that there are two digits repeating. Isn't it? 13, 13, 13 repeating. As I said in the previous solution, that when one digit is repeating, you will multiply with 10. If the two digits are repeating, then you will multiply with, yes, 100. So what will you do now? Yes, equation number 1 multiplied with 100. If you multiply it with 100, then it will become 100x is equals to, isn't it, 100 times x? Equation number 1, this equation is multiplied with 100. Then 100 times x. Then if you multiply this by 100, then it will be, yes, 13.131313 and so on it will go, because 131313 it is repeating. So after this also there will be 13. We have written only 4 times or 3 times 131313. So it is equation number 2 we have considered. Now the same procedure that we have to follow. That is, we are going to subtract equation number 1 from equation number 2. That means equation 2 minus equation 1 when you do, then left hand side minus left hand side will give you 100 times x minus x, and right hand side minus right hand side will give you 13.131313 repeatedly minus 0.131313 repeatedly. It will go 100 times x minus x, it will give you 99 times x. And that side, after the decimal, if you observe carefully, then there are only 1 3 1 3 1 3 1 3, and after the decimal this side also there are only 1 3 1 3 1 3 1 3. So if you subtract it after decimal, there will remain nothing, that means 0. Then front side of the decimal, this side, yes, there is 13, and that side there is 0. So 13 minus 0 will give you exactly 13. Now look at 99 is multiplied with x. If you shift this 99 the other side, it will give you 13 out of 99. Okay, x was considered as this, and this was the question. That means 0.313 bar. Therefore, 0.13 bar can be expressed in the form 13 by 99, which is the fraction form, that is p by q form. Okay, so these are the two simple solutions that we have discussed under this video, and I'm going to give you a few more such type of questions to solve, to practice, and if possible you share your solution. Okay, there are the two questions. Okay, you can practice these two questions, you can solve, and you can send it to me. Okay then, thank you.